Welcome to homework.
Okay, so we have initially uh, NH4, which is ammonium, and then CH3COO, which is acetate. So we have aqueous ammonium acetate. And the question is whether this will be basic, acidic, neutral, or if there's not enough information to predict. How do we determine? Well, what we're going to do is cut these between cation and anion and determine whether either is, say, the conjugate base of a strong acid, or is itself a strong, sorry, if either side is the conjugate base of a weak acid, conjugate acid of a weak base, or if it is a weak acid itself. So let's identify what type of species ammonium is. Is ammonium acidic? It's a basic, strong, weak. Ammonium is a weak acid. Okay. What about acetate ion? Well, it's the conjugate base of acetic acid, right? So this is a base. Right. So if we have a weak acid and some base, can we predict whether the solution will be acidic or basic? Well, unless we know the relative strength of the acid and base, we cannot. So this is not enough information. Okay, let's look at KF. So potassium is our cation, fluoride is our anion. Potassium is going to be a spectator ion, right? It is the conjugate base of strong acids, right? Like strong bases, right? So potassium hydroxide, et cetera, et cetera. This will not in any way participate in acid or base reactions. What about fluoride? Fluoride is the conjugate base of a weak acid. Right? Which means that it is a base. So if we have a base and something that's not basic or acidic, that means our solution will be basic. Okay, next one. We have, again, ammonium, I should say, and iodide. Okay, well, ammonium, that's a weak acid. And iodide is the conjugate base of a strong acid. So this is neither basic or acidic, right? Potassium was the conjugate acid of a strong base. And so it's neither. Iodide is the conjugate base of a strong acid. So it is neither acidic nor basic, simply a spectator ion. So we have a weak acid and then something that's neither acidic nor basic, which means that our solution will be acidic.